In section 3, we're going to talk about how to incorporate XR into your content. Now, XR seems to have great potential in medical education, so what else do you need to consider in order to think about adding it to your curriculum? First, we're going to review what does the literature say about XR. Second, we're going to look at considerations for adopting XR into your curriculum. And then finally, we're going to talk about whether it's feasible to make your own XR content. In this section, we're going to review the current medical literature regarding XR in medical education. So a lot of the promise for XR is highlighted in the 2020 EDUCAUSE Horizon report on teaching and learning. And in this report, they state that XR technologies are the ones to watch because of their potential to support skills-based and competency pedagogies, expand the range of hands-on learning experience, and enable high-touch, high-cost learning experiences to be scaled up. Now, all three of those aspects are seemingly really crucial parts of medical education that we should definitely look into and should consider adding based on that description. Now, the report does highlight that despite this potential, it is clear that higher education, as well as medical education, is not leaning into XR wholesale or naively. So let's take a look at why that is. When we look at those three areas of knowledge, skills, and empathy, let's take a look at what the literature says about those. Now, for knowledge, there were two large reviews of the medical education literature to examine the evidence of XR in anatomy education. The first, by Bolick, Jung, and Henson in 2021, was a meta-analysis on the effect of AR compared with traditional anatomical teaching methods on learning outcome. And they've had two specific outcomes. First is they found no significant difference in anatomic test scores between the AR group and the control groups. However, a subgroups analysis on the use of AR compared just with traditional 2D teaching methods showed a significant disadvantage for using AR. Now, it was interesting because this was often attributed to technical difficulties, that the technology was too challenging to use, and therefore that comparison between the two put AR at a disadvantage. So very interesting that there was no big difference between the groups, but actually AR performed more poorly or was at a disadvantage because of that technology issue from what they found. Now, the second study is by McBain et al. In 2022. And this was a scoping review of XR in anatomy that investigated AR for anatomy education and procedural training across measures of student satisfaction and engagement, spatial ability, performance, and time on task. Now, this study was a little bit more positive. They yielded generally more positive results. And so what did those look like? So for student satisfaction and engagement, AR was regarded as enjoyable by the users and was perceived to increase user motivation. Under spatial ability, it was not clear whether scores improved following the use of AR in anatomy and procedural training. For performance, AR consistently showed better achievement of objectives, and for time on task was found to be increased with the AR studies, though the outcomes were quite mixed. So in a sense, overall positive or neutral, with some areas that showed some promise for AR. McBain also cautioned that while the evidence seemingly points to AR being better than traditional methods, it is important to consider that this was not unanimous across all investigations. Additionally, they found that AR significantly alleviates some of the cognitive demands, mental demand, physical effort, temporal demand, effort, performance, and frustration compared to traditional didactic learning. Let's take a look at three additional notable studies. The first, by Henson 2020, was comparison of a cross-sectional anatomy usage to an AR tool and found that the cross-section group showed significantly more improvement on test scores compared to AR. A second study was using HoloLens to learn musculoskeletal anatomy compared with cadaveric dissection, and it found no difference between the performance in the two groups. And a third study was a novel pilot that combined AR and 3D printing compared to cadaveric learning and found similarly that there was no significant difference between the two learning methods. However, in this one, students did report more enthusiasm and interest for this new tool over the existing tool. So again, the 5 studies we talked about there showed no significant, consistent improvement for XR over traditional teaching. Let's talk about clinical skills. So this one had 2 large systematic reviews of the medical education literature to examine the evidence of XR in clinical skills training. The first study by Bartite et al. In 2021 used 25 studies with head-mounted displays for skills training, which included unique scenarios such as surgical procedures in the OR, IV catheter insertion, surgical knot tying, rapid triage, and urinary catheterization. And for this study, the analysis suggested that XR was non-inferior to, or at least as good as, traditional teaching methods. The second study by Ryan et al. In 2022 involved 17 studies using VR/AR to address topics such as clinical deterioration, multidisciplinary team rounds, IV catheter insertion, interprofessional skill training, breaking bad news, and resuscitation training. And this study found that learning gain is equal with immersive technologies when compared with traditional approaches. They also found that student satisfaction, self-efficacy, and engagement were all increased with the use of XR technologies. An additional study that blends clinical skills and knowledge was a novel pilot using 360-degree virtual reality video as prep material for an obstetrics and gynecology clinical experience. The goal was to investigate the impact of VR on specific knowledge retention for C-section surgeries. This found no significant difference between the intervention group and the conventional study group, but the results reflect the studies that were performed previously that shows kind of non-inferior, they were as good as. Additionally, 83.4% of the VR group reported that more videos should be used in training to prepare for surgical procedures, implying that the users felt that there was value there, even though it wasn't seen in the data looking at performance outcomes. When we look at empathy, this is a newer area of VR research, so there aren't as many studies to look at, but here are 3 great examples. One by Rueda and Lara in 2020 cautioned about VR as, quote, an empathy machine and advocated for informed use and creation of content, specifically using a technique called virtual reality embodied perspective taking, or VR EPT. Really interesting article if you are interested in this topic. A second study by Roswell created a VR experience where participants were experiencing microaggressions, macroaggressions, and racism. And the majority agreed that VR was an effective tool for enhancing empathy, about 95%, that the session enhanced their own empathy for racial minorities, about 85%, and that their approach to communication would change, 67%. So Roswell 2020. Again, the references listed here in the video are all below in the section called Additional Resources. Finally, the third study here by Ventura et al. In 2020 was a meta-analysis of 9 articles that revealed statistically significant positive changes in perspective-taking outcomes after VR exposures, but they did not necessarily note changes in empathy. So when we look at all these studies combined for each of the 3 domains, this term inferior often comes up. So why is XR often considered non-inferior? The first and foremost reason is that small sample sizes are used in most, if not all, of these studies, hence the reliance on scoping reviews and meta-analysis to give these more power, more academic power, more research power to make decisions. Additionally, XR content is sparse. It's siloed, and it's not always cost-friendly. So it's not like someone who's interested in the topic can easily pull something off the shelf and try it out at a large scale to get the data they need for a good quality study. Also, most of the studies are comparing XR head-to-head with traditional methods. And so it makes you think, is that the only role for XR? Should XR be used as a complete replacement for traditional methods, or is there a role for it to be an adjunct? And there's an interesting quote by Zweifach and Triola in 2019 that said, "Some educators really just see no reason to stop using traditional educational approaches that have continually demonstrated efficacy." So there's a bit of, I wouldn't say resistance, but there's a bit of a challenge in moving from something that's, quote, tried and true into a new area that's not well determined. So keep these points in mind when reviewing the medical literature on XR.